right, we are looking at two-way frequency tables today. This is the last lesson of Unit 5. Unit 5 super short. And so this is the last thing, or Unit 7. This is the last thing that's going to be on your Unit 7 test. So two-way frequency tables show us how often two events happen in relation to each other. So if I were to ask everyone in the room a question, or two questions, I can then put that on a two-way frequency table. So if I were to ask all of you guys whether you prefer summer or winter, and whether I were to ask all of you guys whether you have first lunch and second lunch, I don't know why we would need to know this information in comparison to each other, I would then be able to come up with a table of the people who like summer and have first lunch, like summer and have second lunch, like winter and have first lunch, like winter and have second lunch. So if I were to ask you two random questions like that, I would be able to look at a two-way frequency table. Yes? Okay, yeah, that's a valid question. Okay, so... Yeah. All right, so I was just trying to come up with an example that you guys would be able to understand. So each row and column of your table, how do you spell column? Yeah, it is. Must add up to its total. The rows are going to be totaled all up to the right, and the columns are going to be totaled at the bottom. So that would be the total number of people who liked summer and the total number of people who liked winter. The total of all of those rows is going to equal the total of all of the columns. Come grab a note sheet, please. And that's going to give us one grand total in the bottom right-hand corner. So that bottom right-hand corner is going to have a grand total for us. Okay, and then the last thing, we are going to be finding percentages to answer some questions on these two. So for our percentages, we are going to do part divided by whole times 100. You just need that for now. Yeah. What? I can't hear you.
Is it recording or no?
Yeah, it is.
Okay.
Yeah. Hey, any questions so far? I think once you see examples, it'll make sense. Okay, our first example is about a backyard cookout. This would be a cookout, not a barbecue. I don't like when people call things barbecues when they're just making hamburgers and hot dogs. That's a cookout. In order to call it a barbecue, you have to be like smoking or grilling meats. Also, I'm a vegetarian, so I don't know why I care about this so much, but I am passionate that if you're going to call it a barbecue, you got to serve barbecue. You can't have a barbecue and then just have hot dogs. Anywho, 200 people were asked if they prefer hot dogs or hamburgers. 80 of those were kids, and 88 people preferred hot dogs, and 53 of those were kids. So we are going to fill in all of that information into this table. We're given some of the information, and then we have to fill in the rest using like logic. So the first thing is that 200 people were asked. So that goes in the very bottom right-hand corner because that is our total number of people. Of those people were kids. So our total number of kids was 80. So that would go right above there. So we're going to put in all the information we're given, and then we will fill in the rest using logic. 88 people preferred hot dogs, so the total number of people who preferred hot dogs was 88. And 53 of those were kids. So of the people that preferred hot dogs, kids that preferred hot dogs was 53. So those are the four numbers we're given. 1, 2, 3, 4. Any questions about why we put them where we put them? Okay. From here, it's just a bunch of addition and subtraction, usually subtraction, to fill in the rest of it. So anytime we have two of the three things in a row, we can figure out the third, or two of the three things in a column. So I'm going to start over here with the totals. Actually, I'm covering that up. We knew there were 200 people total, and 80 of them were kids. If 80 of them were kids, the rest of them had to have been adults in this situation. So if we do 200 minus 80, that tells us there were 120 adults. I'm going to grab a different colored pen if I can find one, so we can see the stuff that I'm adding in after. I think this one works. So 120 were adults. Okay, then we could fill in either of these next. So let's do this one down here. So of the 200 total people, 88 of them chose hot dogs, which means the rest of them must have chosen hamburgers. So 200 minus 88 is 112. Okay, we could do this row now. Of all of the kids, there were 80 kids total. 53 of them chose hot dogs, so the other 27 must have chosen hamburgers. So I would do 80 minus 53 is 27. Right, and then the last row here, we need to figure out hot dogs and hamburgers for adults. So we know that of the 88 people that chose hot dogs, 53 of them were kids, so the other however many, is that 35, 25, 88 minus 53? I can't carry numbers correctly. 35 must have been adults. And then to fill in this last box, we can do this number minus this number, or we could do this number minus this number. We would get the same thing either way. So of the 120 adults, 35 of them had chosen hot dogs. 120 minus 35 is 85. Okay. If you are concerned that you went wrong somewhere, you can always check by adding everything up. So 35 plus 53 is 88. 85 plus 27 is 112. 120 plus 80 is 200. Then you can go this way too. 35 plus 85 is 120. 53 plus 27 is 80. And 88 plus 112 is 200. You can also add up these four numbers here, 35, 53, 85, 27. Those four numbers equal 200. Any questions about filling out the table? Okay, on your assignments, to make things a little bit easier, and because we didn't have enough space to put all of this, we already filled out the numbers that I have here in black, so you're just responsible for finishing filling it out. But we have the first numbers in the correct spots for you. All right, we've got a few questions about this table. First one is, which food did more kids like? So look just at the kids. How many kids chose hot dogs? 53. Awesome. How many kids chose hamburgers? 27. So we're just looking at this 53 and this 27. So the answer, which food did more kids like, is hot dogs. And now this pen is dying. I have another. Hey, next one. What percentage of people who prefer hot dogs were kids? So you've got to pay attention to the of people who preferred hot dogs. So how many people preferred hot dogs? Just 88. So this 88 is what's going to go on the bottom of my fraction. So 88 people chose hot dogs. Of those 88, 53 of them were kids. So we're going to do percentages just like how we did for probability at the beginning of the week. We'll do 53 divided by 88. Times that by 100, and we're going to round to the nearest whole percentage, 60.2. 2, since it's 4 or less, stays the same, so it'll be 60%. as you guys are working on your assignments, if you could write down the fraction you do here, so that way if your percentage is wrong, I can figure out whether it's because your fraction was wrong or your rounding was wrong. That's helpful. It'll make checking things faster. Okay, next one is what percentage of adults preferred hamburgers? How many total adults did we have? So look for total adults. 120, awesome. So we had 120 total adults, and 85 of them chose hamburgers. We just need adults. So it's of adults prefer hamburgers. So 85 divided by 120, 85 divided by 120, times that by 100. 70.8 rounds up to 71%. Okay. Any questions about those? Okay, flip this over then. We've got one more example on the back, and then we'll be done. Cars or trucks? 150 people were asked whether they prefer cars or trucks. So our total of everybody asked is 150. "75 country drivers," this is really weirdly worded, 75 drivers from the country, or who lived in the country, were polled. So total country is 75. 50 city drivers preferred cars. So city cars is 50. And 85 total drivers preferred cars. So total cars is 85. Alright, from here, we can go ahead and put everything together, fill in the rest of it. So I'm going to start over here. There's 150 people. Exactly 75 of them are from the country, so the other 75 are from the city. So that's going to be a 75 there. And then we can fill in either of these boxes, or this one actually. The only one we can't do right now is the very middle one. So 50 plus what is 75. That means the city truck has to be 25. And I hope all these people who are driving trucks that look like that too. Straight out of a storybook. Okay, down here at the bottom, 85 total picked cars, which means the other 65 must have picked trucks. So I'm just doing 150 minus 85 to get that. And then to finish these off, 50 plus what is 85? That would be 35. 25 plus 40 would be 65, so this box is going to be 40 here. And then we can check that by adding this across. 35 plus 40 is 75. Okay, any questions about that right now? Okay, we've got 3 questions about the table then. What vehicle did more people like? How many total people liked cars? 85. How many total people preferred trucks? 65. So which one did people like more? Cars. Or just cars are cheaper and more accessible and more practical. Unless you're hauling stuff. Okay, what percentage of people who prefer cars live in the city? So, of people who prefer cars, how many people preferred cars? 85. So that's the hardest part of these, is figuring out what the bottom of the fraction is. How many of, or it says country, thank you. That's what you were trying to correct me on. Live in the country. So how many of those lived in the country? 35. So it's this 35 out of 85. So 35 out of 85. 35 divided by 85 times 100 is 41.1. So that stays 41%. And then the last one is what percentage of country drivers prefer trucks? So of country drivers, how many were people that identified as living in the country? 75. And of those, 40 of them had chosen trucks. 40 out of 75. So 40 divided by 75 times 100. 53.3 stays 53%. Okay. Questions, concerns, emotions, thoughts. Alright, we are going to go ahead and get started with our assignment. I should stop this video. Bye, video.